title of the next keynote really intrigues me. It promises a world where anyone can use a robot. I personally would already be happy in a world in which anybody owned at least one robot, but I'll try not to get ahead of myself. Our speaker received the German Zukunftspreis, or Future Award, in 2017. He was crowned Manager of the Year in 2018. He has an impressive collection of publications and awards, as well as national and international patents. Please welcome the CEO and co-founder of Franka Emika, Simon Haddadin. Hello, and I can see you, Simon. Great to have you with us.
Yeah, hello. Good to hear you. Good to hear. Unfortunately, I cannot be in Berlin. Would love to be there, but unfortunately, due to the COVID situation, I wasn't really allowed to come to Berlin. But we're trying our best to show you a couple of things we're doing here, also in live.
Yes, all right. We still have a little bit of sound from the panel that ended a minute ago, so if we would, I think that's corrected now. All right, Simon, off you go. We're glad to have you, even if it's only virtual. We'll see you in Berlin soon enough, I believe.
All right, thank you so much. So, yeah, welcome from my side again one more time. My name is Simon Haddadin. I'm the co-founder and CEO of Franka Emika. This talk will be about the democratization of technology, a world that we imagine where everyone can use a robot. And if my colleague could start the presentation, can you already see it? Because unfortunately I can't. I cannot see anything. And this is a bit late. On a screen share? All right. We have some technical issues, unfortunately, apparently.
Well, we can see your slide now.
Ah, you can see the slide.
We can see the slide, right.
Thank you so much. Maybe take this one away because it's a bit a minute later, and I always assume this is actually the live one. So if you see the images on the very first slide, we see a couple of groundbreaking tools that have been developed over the past centuries that levitated humanity on the next level, enabling us to create new things with our hands, basically. And for us, robotics is in that very same group, a tool for humanity that will ease in our life, that will relieve us of strenuous, tedious work. Our vision at Franka Emika is to create robotics technology for everyone. And for that, I would like you now to start the video that I shared for you. Yeah, it's running okay. So basically, we launched our very first product roughly 2 years ago. The world's first AI-enabled robotic tool. It has a completely new type of performance. I will show you a couple of later. We have designed, developed, manufactured the entire system here in Germany in our manufacturing facility, basically where robots build robots. A robot is, as we used to know, not a difficult machine anymore that only experts and professionals can use, but we also gave a completely new software stack so that everybody by now can use a robot even in complex scenarios. The robot system itself is for us not only a robot, but it's actually the extension of the digital world in the physical world, into the physical world. And I'll show you in a couple of seconds what we actually mean by that. When we started launching our product, we not only released
Simon, just one thing. We did not hear, we almost did not hear anything that you were telling us because the sound of the video and the music was quite loud. So if there was important info, right, then next time you should either mute the video or maybe you can just explain what you told us because it was very hard to understand. But the video was great.
Okay, so right. So I asked to mute the video. It's not a big problem. So what I said in a nutshell is basically that roughly 2 years ago we launched our very first product, the first AI-enabled robot system in the world, and we basically combined our skills of algorithmic, of a software operating system, combined with the highest mechatronic density, meaning that the robot system is actually learning capable, meaning you do not need to program this robot anymore, but you can just teach it by demonstration, for instance, or you can just deploy robot apps, which are tasks or features robot has to do, and you do not need to program anymore. You can use our cloud system, Franka World, and you can download your apps and skills onto your robot system, whether it's here or whether it's in Japan, it doesn't really matter anymore. By now, we are engaging with a large community. Our community is primarily the industry, the disruptors, the educational space, and the academic space. Industry for us, the prime is the 3C manufacturing, meaning consumer electronics manufacturing. Disruption space is basically what we are doing here. So people who are trying to give robot systems new capabilities can use the robots for new applications in food sciences, in health, or in finding out how does AI work in the real world. Education is for us also very important, as the knowledge in robotics is actually very limited. Only few people only have access to robots and to knowledge in robotics. So we partnered with educational bodies, with non-profit foundations to bring knowledge of this kind into the general population. And the fourth, the academic space, is basically our, let's say, influencers, those people who know robotics best, who know control best, who know AI best. And by now, the biggest labs like Stanford, MIT, Facebook, Google, etc., they're all using our robot systems to understand and learn about AI applications in the real world. And basically, what we are doing, to put it in a nutshell, is what Apple did in the computer space, is what we're trying to do in the robotics space. And now I would like to ask my colleagues to turn around the laptop, because I only see everything 1.5 minutes later. So maybe turn it around for a second. Yes. And then we go on the next slide. So, um, So what I just mentioned is what we're doing here is basically a fusion of software and hardware technology into a single product, which is very simple for most people, or all people at some point in time, to use. And why do we do that? Because a major milestone in technology already happened. We already are living in a world where everyone can use a computer. On the left side, if you Google computer nerd, you see, unfortunately, still this image. It's the few people who were able to program a computer. And then roughly 30 years ago, Mac or Apple came around with the Apple One, with the idea of a personal computer. And by now, we see the world where everyone uses a high performance high performance computer in their everyday life. Next. Now, why is it that robotics is not on the level where computers are? And why are manufacturing facilities still look like what you see here on the screen, specifically in the biggest manufacturing market in the world, that is the so-called 3C manufacturing market. 3C stands for computers, communication devices, and consumer electronics. So everything we use every day on a daily basis, none of that is manufactured in Europe anymore, because our labor costs unfortunately do not match the requirements anymore, and these things are impossible to automate. So everything was outsourced into low-income countries, and this is, on at least in my point of view, a major gap, because the biggest market in the world, and Europe, doesn't have any part in the value chain. And why is it not automated? It's not automated because robots are not usable, they're too expensive, and they're not capable to perform the tasks that a human can perform. And that is why, next slide, we only know this type of industrial automation. Everything behind a safety fence, no flexibility, and those robots can only drive from A to B. They can paint, they can weld, but they're not able to assemble or to test or to grasp something in their hand. And that's unfortunately one of the outcomes. Is 2 years ago, we have this press release from Süddeutsche, it's a German newspaper, telling us Europe's last PC factory just shut down. And I think everybody understands that this is a major problem, and we're trying to solve one of those problems. What we have done, we basically built an electronic system here in Germany. What you see there is our manufacturing facility, a former Nokia Siemens facility that we have reactivated. And when you click on the next one, and now please turn off the music. What you see here is our manufacturing facility, where basically man and machine are building robot systems in order to be even competitive against low-income countries. We need to automate as much as possible. Unfortunately, something doesn't work right now. And we're trying to give this technology basically to everyone so that we can deploy automation also here in Europe again, bringing mass jobs also back, but only we can do that by combining man and machine, so we are somehow competitive with low income countries. Now, where is one of the challenges? This is an article from Handelsblatt, which shows kind of where does Europe stand against China, where does Europe stand against the United States, and what we see is a fast-running runners, and we have a slow industrial robot trying to follow these guys. Now, if you go to the next one, what we also know is that what has happened, or yeah, over the past 2 decades or longer in those technologies in AI. What we see here is 1996, Deep Blue beating the former, so back in the days, the world champion in chess, Garry Kasparov, and Deep Blue managed to beat him in a chess game. 20 years later, we have on the other side the challenge of Deepmind, Google's Deepmind, beating the world champion in Go, which we all assume are major advances. But who the hell is this guy? So for some reason, we managed to build a brain that can do better moves than a human, but we did not manage that the system will also conduct the movement. So we put a person, a faceless person. So all we have managed at some point, you can say, we only managed to exchange the guy who does the move for the computer. Next. But when we think about AI, all of us, I think we still imagine all the science fiction movies we have in mind. We're thinking about Data from Star Trek. We're thinking about C-3PO, and we're thinking about Agent Smith from the Matrix. All of them have something in common, is because we believe AI is actually something happening in the real world. Yeah, even if you take Agent Smith, he only became very powerful when he actually entered the real world and did not remain in the digital world. Manipulating the digital world is much easier than manipulating the physical world, and that's why you go to the next screen. Sorry. So what we see here is the so-called DARPA Robotics Challenge, where we try to solve with a lot of colleagues from all over the world, basically building scenarios of catastrophic, so Fukushima, sorry, Fukushima-like incidences where we can deploy robots and we can sit somewhere in a safe space and we can control robots and send robots to solve our tasks. But this is what the brightest minds try to solve, and what you see is that they cannot even walk on stairs. Next, please. And why is it so? Click what? One more click, please. The sound. I'm really sorry about the sound. We should have tried. So what you see here is now, what is the big difference between mobility and manipulation? And I think, as we always try to use the human as a role model, it's the same in this case. What we see here is for millions of years, organisms were able to move from A to B. But only primates are able to use the world and build tools to manipulate. Manus, so manipulation comes from manus, the hand. So only primates are capable of manipulating the world as they want to. And this is what we've been trying to do. So in general, AI is something like sense, plan, and act. So, but why is it by now a common assumption that it ends on the screen and it's some major big data computer running in the background? But we cannot do the transfer in the physical world, and this is what we are trying to do, and this is what you see here. The human on the left side with his capabilities, I can feel and I can use my muscles to manipulate the world. And this is basically what we gave robot systems. Next, please. And why do we do that? Because we want to give another one. We want to give as I'm really sorry about the sound all the time. So we want to give people a tool at their hand. What you see here is the bike manufacturer Puki. It's a children's bike manufacturer. And in disabled workshops, actually, these bikes are being manufactured. And we can give now even people who have limited skills a robot tool that can help them to assemble these bikes and then go next. And what I would like to take you on along now is a small demonstration of where we think AI does not end in the digital world, but actually bring it into the physical world. And basically, I will show you, or we will show you 3 steps. We will show you learning by demonstration. So we can teach a system to do something and the system will conduct it. On the second scale or second level, we will show you how a robot system without any knowledge about the concrete task can learn itself how to conduct the task. And the third one is how can I give a collective learning? So the robot system in China, in the US, in Europe, it doesn't matter, can all share the knowledge and bring it onto a single system. And for that, we will go now into our lab. As I said, we wanted to be in Berlin, but we're trying to make this experience as hands-on as possible because robotics is hands-on. And I wanted to bring a robot actually, or at least one robot onto the Berlin stage, but we're using our lab for these days. So we are here in Munich, Schwabing, in our headquarters, and this is one of our major labs where we'll show you a couple of applications and skills that our robot systems have. So first of all, so maybe you swing a little bit. I hope everybody can see. You can see here a small fleet of robot systems. This very first one, what you see here, he's trying to follow a path. And what I can do, I can interrupt him. And even if I interrupt him, the robot system will still try to follow its path. And kannst du mal collision detection anmachen? And one major skill that every robot system needs, it needs to be safe to interact with humans. And for that, we basically gave the robot a reflex that the human has. It's the sense of touch. So every interaction I have with the robot can feel it. Kannst du zero G machen? Now, another capability is basically this robot is not a mechanically stiff robot, but it's like my human arm. I can have it strong or I can have it loose. And this robot actually weighs almost 20 kilograms, but I can move it with my little finger because the robot keeps its own weight or compensates its own weight, and that makes it very easy to guide and to move around. And why do we need these skills? Sense of touch, collision detection. For a purpose of manufacturing, we need those things to conduct these tasks. I hope that everybody can more or less see what we're having here, but these are typical tasks from electronics manufacturing, and I will show the robot basically how to insert this plug or this plug and taking them from over here and I'm not sure if you can all see in the background. Maybe if you lift it up a little bit. I don't think anyone can see it properly, but this is our programming interface, so you don't, no, just stay there, it's all right. You don't need any codes anymore, any special computers, but what you see is that through the browser, we logged in onto the robots. So we don't need any special computers anymore. And what I do now, I basically show the robot how to insert this plug, and I will show the robot how to insert this plug. And now if you can, I will push play. I will put these over here. And what you will see now is that the robot will try to do exactly what I just showed him. And he's picking up this very, let's say, complicated plug. And what you will see now is like a blind person, he's trying to wiggle this plug in until he reaches the goal that I just showed him. So you still see those wiggling motions. And now he managed to insert it. So he's moving backwards. And now he's picking up an Ethernet. Oops, just pushed, turned off itself. Nice. Oh, no, now he's, huh? That's how we know it's live, yeah? Now, where is the Ethernet? There it is. Okay.
Simon, while you're trying to start it again, so will he always have this little janky motion that you showed him, or will he be able to optimize his movement after you showed him it once?
Okay, then let's continue to the next room. I'll show you right away.
Great.
Because basically what the robot used here is inherent capabilities that somebody else gave him already. And he will try, with the capabilities he has, he will try to solve this task. And now we will show you where does he learn how to solve these tasks. And that is what we basically call self-learning. So the robot, again, to conduct these tasks, we will go to the next station. Maybe we show here this real quick. So what we see here is a couple of assembling robots, basically testing and assembling iPhones and packing them for shipment. And we have to move a little bit further. I'm really sorry. And now turn a little bit. What we see here in the background, maybe you see a computer assembly. So that's where 3 robot systems are basically assembling a computer. And now I'll show you how the robot understands and learns how to conduct this insertion. Come on, play. So what we see here is now the robot wants to insert this USB-C port connector into this socket. So it's a USB-C insertion problem. And these are the biggest problems in automation, how to insert objects. And what we see here now is that this robot is trying to insert, and he's trying different types of strategies. He's using force data, he's using motion data to understand how do I insert this plug. And this knowledge can then be transferred to either this robot or another robot to perfectly insert this specific USB-C plug. What do we do now? Huh? You have trained? Yes. So we have trained now, and now let it play. So basically, no more programming. Nobody is sitting around programming here, but the robot is basically learning itself. And now you saw it went in right away because he understood what is the best strategy to insert this plug. And he will do it just like a human when you think about you're in your hallway and it's dark and you're trying to insert the key into your lock. And that's exactly what this robot is trying to do here. Now, maybe another one. What we can show you now is monitoring, right? So now the robot understands this is my perfect way of how I will conduct this task. So every obstruction, every difference in this way will be felt. So even if I put a balloon here, the robot will feel this balloon, and I can restart everything just by touching him. And then he will conduct his task again. And I can put this balloon, it doesn't really matter. I can put it here, I can put it there. The robot has a sense of touch all over the body. So that means the process we want to automate will be much more robust, and the task will conducted very fast. Now, we kind of still have to program a robot by using different apps we give the robot, but sometimes it's a bit difficult to know what apps do I actually need. And this is what we'll show you here now, is understanding. Can we zoom in on this screen as close as possible? So what you see here is basically the dashboard of the robot. And now our colleague will basically will show the robot what to do. Usually you have to pick the apps into your timeline. And now go a little bit backwards. Now please teach the robot. And this is the second level of learning by demonstration. So nobody needs to tell the robot anymore what apps he will use. He will understand by pure guiding what happens here. And he will accumulate and segment by understanding the process and put them into modular building blocks by himself. So what we just saw is that automatically, just push play, automatically this timeline filled up without anyone telling the robot what to do. He just understood what he has to do. And then we can just conduct the task, and the robot will grasp the object and will put it there where it was shown to. So what we saw before was we have to give the robot the apps that he needs to know, but now we don't need to do this anymore. The robot understands himself. And now a quick view on the, right, I'll see the picture, is what you see here is basically, that's where a lot of those data is accumulated. It's basically a robot farm where constantly, all day long, robots are trying to see and grasp objects. We have here stiff objects. We have in the back, you see compliant objects like toys and stuff. And in the middle, we have insertions. So that's basically where we generate this data so that the robot systems understand how to conduct and how to solve different tasks. Now we could go back onto the demonstration to the next slide, please. We're almost on the in the end. So why is this important? So robotics currently, we see that we are lacking major automation steps. And our entire industry broke down because if you look at the left side, this is 3C manufacturing. Under COVID situations, it's no way that this manufacturer can still run. So if we deploy robots, we can even keep social distancing in manufacturing facilities. Next one, the same accounts for healthcare. we are exposing our healthcare professionals all day, every day to a potentially deadly disease instead of using robots that can actually do the task, that can actually take the nasopharyngeal swab so that our healthcare workers don't need to do that anymore. Another system failure. Next one, please. And even at home, we are having so many people that are stuck at home. Nobody takes care of them anymore because they're not allowed to do it anymore. So robot systems again can help us to engage with our elderly, to help them, to assist them in their taking their drugs, taking their food, and again, everything ends on the screen, but we do need physical agents to block this gap. Next one. And for that, I would like you now to start the other video I uploaded to you, because one major thing in robotics and in every technology is to bring this knowledge to everybody. What you see here is now a glimpse of that, what we're doing. So we're trying to teach and to bring this knowledge to even to the youngest people, so we can create an entire generation of robotic natives, similar as digital natives, but then not just ending on a computer screen, but actually interacting, bringing these things into the real world. And then go on to the next slide, please. Not only on a let's say gaming level, but we actually created together with the Industrie- und Handelskammer, this is the professional training facility in Germany, to build courses for everybody so that we can bring this knowledge not only into homes, but actually into schools, into industrial training facilities. And from there, we can scale, obviously, from trainers to learners, and then they can bring this knowledge into their work, whatever it is they do. Next, please. Now, if you remember this image, this was from Handelsblatt. And of course, we see there is a lag in Europe against China, against USA, but we don't think this accounts in robotics and mechatronic systems, which are actually the gap or the bridge givers between the digital and the physical world. And that's why after this image, we made a counter image, which looks like this. Because we believe in mechatronics, in mechatronic systems, in cyber physical systems, Europe is not behind, but we're actually number one. And if we manage to do that, to train our people, to make systems affordable, to make them usable, to make them safe, then we can, from being a factory assistant, because this is what currently reality is, we can do the next step into service applications, whether that is health or food, for instance, and then at some point in time, of course, want to bring robotics into everyday life. And then I thank you very much for your attention. And if there's any questions, I'm very happy to answer everything. Thank
Wow,
you so
first
much.
of all, Simon, let me say, wow, there's a lot of excitement in the chat. I'm very excited. Please
you.
don't feel bad because you had the music turned up at the beginning or because you were talking to your people to change the slides. This was a terrific presentation. I think I can speak for everyone that it was as much as we would have loved to see you in Berlin. It was great to have a look at your workshop, right? And basically watch your work in progress. So big compliments, kudos to you and your team. There are
Thank you very much.
indeed a couple of questions, and since we are, I mean, we'll take a couple of minutes, but since we're almost done, please answer them briefly. One question is, could these robots solve a child's jigsaw puzzle?
Yes.
Great, great. Very, very nice and concise answer. I think next
you asked
answer
for a concise answer. So.
next answer will probably be a little bit more elaborate. What's your understanding of?
So maybe let me give you
Sure.
Real quick. So we are using the human as a role model, and I have children. We all have children, and if you see at when our kids grow, I mean, in the beginning they are starting to understand their own body. You see that when they're lying on their back and they're just moving their hands around. I mean, this is the years when kids are learning their own body. And then we are giving them toys like cubes and circles to insert them into these toys, like a jigsaw puzzle. And then understanding this insertion, they will transfer this knowledge. And if you give a 4, 5, 6-year-old a key, that's why I said that before, if you try to let them insert a key into the hole, it will take it some time, and they needed years of training to do that. And basically, what we showed here is that we can use the same skill, but train them within seconds. That's basically what we're doing here.
Right, fantastic. Next question is, what is your understanding of the timeline until every other household has robots like this at home, maybe even ones that are not only arms, but full body robots?
So every other household is a different question. If you ask my household, it's yesterday. But let's say if we actually want to deploy these in masses, I used the analogy of computers in the very beginning. And if you look at the computers, we have a little bit similar story. We had giant computers to do very rudimentary tasks, and it took 20, 30 years until everybody has a household PC at home. And we believe that roughly in the next 10, 15 years, the systems will be in that way affordable and capable and safe that they can actually be bought, let's say, at MediaMarkt in the Christmas shopping time.
Right, thank you. Another question.
Or bought on Amazon, obviously, by now. But
Yes, yes, of course. Are the robots available for individual developers or only for companies?
No, so basically we have different tracks. So obviously our prime business is B2B to major corporations, but that's why I mentioned real briefly our so-called disruptors track. That's where basically people who want to use the robot system as a platform. So the mechatronic system and our software to create new tasks, basically everybody can order these things.
Right.
And the price is roughly either 1,000 euros per month as a service, or there's packages from something like 12, 13,000 euros to 20,000 euros. So you need to have a little bit cash, but yeah, that's more the issue if you can afford that on a personal level.
Right. Okay. Thank you. Someone says, I believe Franka, Emika, Panda cobots are doing good on the education side. What are the upcoming advanced new features?
So some of them we saw here. So basically, the very first demonstration I showed you, these are the things that we already deployed. So over the next weeks and months, we are deploying the features I just showed you. So basically, learning capabilities, different interfaces. So currently, it's so-called Desk. This is our browser-based interface, but a software developer's interface, similar on like IDE for the smartphone. So you can create your own applications. We have a so-called FCI, which is a Franka control interface, which is a 1 kilohertz interface, meaning you can control the robot all the way onto the joint level. We can use MATLAB Simulink if somebody, most people from control and automotive engineering know that, or you can use, we have one partnership also with NVIDIA SDK, it's called Isaac. So you can use basically all common programming languages to use the robot. Besides the software features, what you see here, I think the video is still running, right? So if you have ever seen an industrial robot, usually they are built on a major platform, and you probably don't really see it, but there is a clamp here. We call this the power paw. Basically, you can attach this clamp to any surface there is, and the control box is hanging into the same cabinet, so you don't need any major infrastructure anymore to buy a robot. Another one we can see here, actually, it's a new gripper, which basically will have or has the same sense of touch capabilities as the robot already has. So these are a couple of new things that are coming up.
Very, very clever solutions. Now it's time for my questions, and they are quite brief. One is the rock band question, and the other is a startup question. The rock band question first. Where does the name Franka Emika come from?
Why is this a rock band? I was thinking
because we always ask rock bands, where does your name come from, right?
Aha, okay. I thought you were going to ask me what's my favorite rock band. Okay.
No.
So Franka Emika is basically, do we have a logo somewhere here? Jesus, on my shirt. So this is Franka. So I don't know if everybody realizes, but this is a girl with a ponytail chasing a ball.
Right.
And basically this girl, because the logo existed first and the logo needed a name, and we wanted a German name that is, let's say, understood everywhere in the world. And then it was, we are a bit older at the time. Franka Potente was still a name. Now nobody knows her anymore. And that's why the name already came from there. And there's, of course, personal connections, but this I would like to share maybe in a biography at some point in time.
Right, great, interesting. You see that it was also a rock band answer. And now for the startup question. So what are you looking for at the moment? Are you looking for funding, for customers, partnerships, employees? What are you looking for?
Probably you can make a check everywhere. I mean, we've been growing heavily over the past years. Of course, this year was a bit different than all other years, and I hope that everybody who listens is coming along quite well, health-wise and business-wise, because the year was a bit tricky. Basically, currently we are, let's say, coming back a little bit from a small hibernation mode, and we are scaling up heavily. So we are currently raising capital. We are recruiting heavily. We are expanding again our partnerships with especially our industrial customers. But the biggest thing that I would like to share here is, of course, that I would like everybody to get robot systems, whether it's at home, at your company, get our app development kit, get our control interface, use the robot to solve whatever problem you have, put it at home, it makes you orange juice, coffee, everything you want. And this is actually my biggest wish for today, that the entire community, especially German and European community, will use robot systems to solve all problems that are happening in the physical world. That will be my wish.
Great. So once again, thanks for the great presentation. What a great way to end the program today here at Future Space. Simon, have a lot of success, and thank you very much. I think a lot of care and preparation went into showing us all these different things. Thanks a lot, and greetings to your team.
Thank you very much. I will tell them.
Thank you.
Very
Take
much.
care. Bye-bye.
Bye-bye.